Okay, we're going to do lesson number 10, questions number 2, 4, 5, 7, 8, 12, 24, 25, 29, and 30. Oops, let me start with the first page. That's our second page. Here's our first page. Okay, question number 2 says use the words perpendicular and parallel to complete the following sentence. In a rectangle, opposite sides are blank and adjacent sides are blank. So let's think about our rectangle. All right, opposite sides, which would be this side to this side or this side to this side, opposite sides run parallel to one another. So A is going to be parallel. And then adjacent sides means the sides that are next to each other. So this one and this one, this one and this one. And if you think about those as lines, they intersect at 90 degrees, so they are perpendicular. All right, question number 4. What percent of the rectangle is shaded and what percent is not shaded? Okay, we have a rectangle here with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions. So each division is going to represent 10%, because if we take 100%, which would be the whole, divide it by 10, we get 10. So each one of these sections represents 10%. So we have 10, 20, 30% that is shaded, and that means we have 70% that is not shaded. Right, question number 5. Write 3 2/3 as an improper fraction. Okay, so when we do improper fractions from a mixed number, this is a mixed number, it has a whole number and a fraction together. You're going to take your bottom number and multiply it times your whole number right here. So these two, we're doing multiplication. So 3 times 3 is 9. And then you're going to add the top numbers. So 9 plus 2 is 11. And it's 11/3 because we're dealing with thirds right here. You can also think of it like this. We have 3 whole numbers, and because we're doing thirds, we have 3 over 3 is 1 whole, and so if we were to add 3 of those together, we'd have 3 wholes plus an extra 2/3. And 3 plus 3 plus 3 is 9, plus another 2 is 11/3. So you can perform this question a couple of ways to get the answer, but your final answer is going to be 11/3. Okay, question number 7. Point M represents what mixed number on this number line? And so because it's a mixed number, we know that we'll have both a whole number and a fraction. So when we look at our number line, we see our whole numbers, and our point M is between 9 and 10. So we know that we have at least 9 and then a fraction of the next whole number, a fraction of 10, but we won't go all the way to 10. So we know that 9 is going to be our whole number in our mixed number, and then our fraction, we look and see how many sections is this whole number divided into, and we can count them. We have 1, 2, 3, 4, 5, 6 sections. So we're going to have, our fraction is going to be out of 6 sections, how many does this number represent? And so if we move over from our whole number, 1, 2, 3, 4, 5 out of the 6 sections. So our mixed number is 9 5/6. Question number 8. Draw and shade circles to show that 1 3/5 is equal to 8/5. So let me draw my circles here. Okay, this represents 2 wholes, and then we're going to divide it into fifths. So I'm going to do my best to make it look nice and even here, into fifths. All right, so each one of these circles is divided into fifths, and so I want to show that 1 3/5 is equal to 8/5. So if I have the whole number 1, and I'm going to shade all of number 1, and then I'm going to shade 3 out of 5 for my second. So here's 1, 2, 3. And we can see that 1, 2, 3, 4, 5, 6, 7, 8. 8/5 is the same as 1 3/5. So this picture right here is your answer for right here. Oops. Grab my next page right there. Okay, question number 12 is an arithmetic problem with an unknown number, a variable. And so we always need to get our variable by itself. And right here we have a negative z, and we want a positive z. We want to be able to deal with a positive number. And so to get a positive number, we need to move it to the other side of our equation. And so we do the reverse arithmetic function. So we add z to both sides, and we're left with 77,000 is equal to 39,400 plus z. So this was step number 1, but we still need to do another step because we need z by itself. And so because we have a positive 39,400 and we want to move it to the other side, again, we do the reverse arithmetic function, which is going to be subtraction. And we move our number to the other side. A positive 39,400 plus a negative 39,400 is going to cancel out to 0, and we'll be left with just z on this side. And so over on this side we have to do our subtraction. 0 minus 0, 0. Then we turn this to a 10, and we had to borrow, but 6 is smaller than 9, so we have to borrow again, and we're left with 37,600 is equal to z. So z equals 37,600. All right, question number 24. We have 2 2/3 plus 2 2/3. Okay, we have a common denominator here, and so we know that we can just add our fractions across, which makes life really easy. And we have 2 whole numbers, so we can go ahead and add the 2 plus 2, and that's going to be 4. And then we have 2/3 plus 2/3 is going to be 4/3. Okay, so we can add those together and we're left with 4 4/3. But you'll notice that this is an improper fraction, and so we do need to change that into a mixed number. And so 3 goes into the 4 just one time, and you're left with a remainder of 1. 1 part of 3, which is the same as 1/3. So this improper fraction is equal to 1 1/3, but we still have another whole number we need to add that to. So we have 4 plus 1 1/3, and when we add those 2 whole numbers together, we have 5 1/3 as our final answer. Number 25, we have 2/3 times 2/3 times 2/3. And when we have multiplication, we can just multiply straight across the numerators and denominators. So we have 2 times 2, which is 4, times another 2 is 8. And then we have 3 times 3 is 9, and then 9 times another 3 is going to be 27. So our final answer is 8/27. Number 29. Which of these numbers is not an integer? And if you look in your textbook for this number, number 29, you'll see this little number 4 underneath the 29, and that tells you that you can find the information you need to answer this question from lesson number 4. So if you turn back to lesson number 4, in the introduction, it tells you that the definition of an integer is all counting numbers and their opposites. All counting numbers and their opposites. So 0, 1, 2, 3, 4, and their opposites. So negative numbers are counted as well. So a negative number is an integer. 0 is an integer. Positive numbers are an integer. And that leaves us with C as a not integer. It's not an integer because it is a fraction. It's not a whole counting number. Okay, question number 30. If a minus b equals 5, what does b minus a equal? So we're basically doing the reverse. We have a subtract b, and we're getting an answer of 5. And then we're going to see what happens when we reverse the numbers. And so you can plug some numbers in here just to help it make sense to you and to kind of prove what's going on. So I'm looking for a number subtracted from another number that will give me 5. So let's just say I have a equals 6 and b equals 1. And I know 6 minus 1 is going to equal 5. Now if I do the reverse and I go 1 minus 6, what is that going to equal? It's going to give me negative 5. And any two numbers that you plugged in that gave you 5 as your answer, when you subtract them in a similar fashion, you will always find that the reverse is going to be the negative numbers. So what does b minus a equals? It equals negative 5. All right, b. If w over x equals 3, what does x over w equal? And we kind of do the same thing. Think about this whole number, 3. If we were to make it a fraction, like this is a fraction, 3 is equal to 3 over 1. 1 goes into 3 times. 3 divided by 1 is 3, so 3 is equal to 3 over 1. And so we just simply reverse those two numbers and we get 1/3. If w over x is 3, then x over w is 1/3. And how are those two related is what C asks us. How are w over x and x over w related? They are the reciprocals of each other. They are reciprocals. All right, that is lesson number 10.